Hello there and welcome to this week's edition of Engineering and You. It's a program where we bring to you people that have made a mark in the field of engineering, and they are there to share their field with us, to make us understand how engineering affects our day-to-day life and how it's improving us from day to day, month to month, and year to year. My name is Tunelanyo, and this promises to be a very, very interesting one this week because we have our guest in the house who's going to be taking us on something very, very unusual, very new, very strange, but not too new, because if you are used to information technology, software engineering and ICT, then you understand what we are talking about. Let me not let the cat out of the bag of what she's going to talk about. Today, you know that this program is a very interactive one where we don't only get to talk to you, but you get to talk to us. And today, the question that you have to answer is mathematics. And I hope somebody's heart is not beating. Is a father is now 3 times as old as his son. 12 years ago, he was 6 times as old as his son. How old is his son and the father now? So pick up your pen, start working that out. If you know the answer, pick up your phone and call us in the course of the program. The program is sponsored by Prince Engineer Yemisi Shilon, FNSC, and the gift is coming to you via courtesy, the sponsor. So pick up your phone if you know the answer to this question and let us know what your answer is. My guest is already here. Will be joining us via Zoom, and she's ready to let us know what. But before I let you know who my guest is, let's take this very short break. When we return, I will let the cat out of the bag. To have you back, and my guest for today is Engineer Dr. MOJIRADE OLORUNTOBA. She obtained a BSc degree in chemical engineering from Obafemi Awolowo University, Ile-Ife, Osun State, and master's and PhD degrees from the University of Lagos. She is a registered engineer with the Council of Registration of Engineering in Nigeria, Current, and a fellow of the Nigerian Society of Engineers. MOJIRADE is a Deputy Director of Engineering Research at Prototype Engineering Development Institute, and an institute under the National Agency for Science and Engineering Infrastructure, NASENI. She had participated in several engineering projects, garnered a wide range of experience through such projects. She has covered in several capacities at the national division and branch level of NSC and Current, notably as member NSC National Executive Committee 1999-2020, past chairman NSC Elisha Branch 2016 to 2018, and pioneer chairman APWEN Elisha Branch 2012 to 2015, and APWEN Southwest Coordinator 2020 to 2021, among others. So, Engineer Dr. MOJIRADE OLORUNTOBA, welcome to Engineering and You this week.
Thank you so much for welcoming me. Thank you so much.
All right. The topic to be discussed today is design skill and computer-aided manufacturing. So I'll hand you over to Engineer OLORUNTOBA to put us through what this is all about.
Thank you, Mr. Tunde, for bringing me here. I will start by just doing a brief introduction of what the topic for today is all about, and it has to do with design skills and computer-aided manufacturing. Let me try and define what skills are. Skills are what most of us talk about and we are so familiar with. And we all know that there are different kinds of skills, There's the soft one, there's the hard one, and amongst the hard skills that we have, technical skill is part of it. And when we start categorizing the different technical skills that we have, there's no how we won't mention skills. We know project management is a skill on its own. Project writing is a skill on its own. Technical writing is a skill on its own. But for this evening, we'll be emphasizing on design skills, and that has to do with ways in which we concept an idea and we try to interpret it so that people can understand in a technical way. So that is just an introductory aspect to design skills. Then when we talk about computer-aided design, from that name, computer-aided design, that means we are trying to make a design through the help of a computer. You know, we are trying to express a concept through the use of computer. You know, basically in engineering, when we talk about, by the time we want to design a project, when we have a project to design, the first thing that comes to mind is conceptualization. We have an idea. We just felt, we saw something, we have an idea which we want to bring into a product. So by the time we have that idea, there are some steps that we need to follow in order to be able to manufacture that particular product that we have in mind. So one of the steps that we need to do is that we need to design, we need to do a model of that particular design product that we have in mind before we now go further on to do the manufacturing of the product. So like I said earlier, I've tried to classify the different kinds of skills that we have, and I've talked about the technical skills. Basically, skills are additional knowledge that we need to have in order for us to perform in a particular specific job. And like I said earlier, I said we have different kinds of skills. Some people are very good in programming, some are data analysis, some are good in project management, some are in technical writing and stuff like that. We shall be considering the design skills for this particular presentation. And like I said, when we talk about design skills, every aspect of engineering deals with design. Whether you are a civil engineer, a chemical engineer, an electronics engineer, every field of engineering deals with design. And even design is one of the things that we did in school while we were in school. So there's no how that an engineer can ever run away from design. So like I said earlier, we'll be emphasizing more on computer-aided design. And the good thing about this kind of design is that it relates to design. And it is what we use to have our model. And there are different ways of representing this computer-aided design. It can be in 2D representation, it can be in 3D representation. Then the good thing about this computer-aided design is that it gives us an opportunity to modify whatever thing or whatever model we are working on. It's just like you know, when you type, let's take a computer as a typical example now, our typing on computer. You know, we have the access of correcting whatever mistake we make on that particular typing that we are doing. We have the joy of going through what we have done before printing out a final product. The same thing with this computer-aided design. We have an opportunity of modifying whatever thing we are modifying. We have, and it's a good replacement for manual drafting of models. You know, initially I talked about conceptualization of a design. As engineers, the first thing that comes to our mind is conceptualization, in which you have an idea to do something. And once you have the idea, the next is that you want to go back to the drawing board, sit down, and try to make a sketch of what you want to produce at the end of the day. And having done that, we are not looking for ways of gathering enough information that can enable you go online, you know, that can enable you enter those information into your computer system. And it is when you now enter those information into your computer system that you can start talking about designing. And like I said earlier, there are different fields of engineering and there are different kinds of software that most times we use for design. Like if you take a civil engineer, for example, what is common to them is the civil 3D software. They use it for most of their infrastructural projects. Then again, for the mechanical engineers, they talk about AutoCAD. Some of them talk about Autodesk Inventor. Then the Pro-E is a good mechanical project software. Then in furthering, you know, we want to further with our design. There are times when we want to do 1 or 2 analysis just to be sure of what we have designed, just to be sure of the model. Then we go further. Some people use COMSOL, multiphysics for that. And for the computer engineers, most times they use what we call Python programming language. There's a C++. So depending on the different fields of engineering, there are different softwares that can be used to do whatever design they want to embark on. So for this particular talk this afternoon, like I said, computer-aided design is what we use to manufacture things now. You know, in every field of engineering, you can use it. Then I'm going to take a typical example. If you look onto my screen now, I have, just because of the people we are seeing this afternoon, I don't want to really go into details like that. But let me assume I have a concept in my mind. I want to develop what you are seeing on the screen. It's an adjustable table with wheels. You know, the first thing that will come to my mind is that I have a design I want to do. You know, I'll now imagine, I want it to be better off than what is already in the market. And that is what we call innovation. By the time I have this idea, I'll now sit down and think, how will I accomplish this thing? The how, the what, the who are the questions I need to answer in this course. And after getting all those things, I'll now do a thorough research on how I want to go at it. The next thing I want to do now is to gather my data by measuring, I'll now decide what is the height of this table I want to make, what is the width, and what is the depth, what I want to make. By the time I have all this information and I write it somewhere, I'm now going to transfer my information, the data I've been able to gather, into a computer-led design. That is when I'll now use whatever software that is suitable for what I'm working on. For this particular case now, I'll be considering Autodesk Inventor. And for this Autodesk Inventor, once I have all my data, the next thing is that I'll go into the system and enter all the information I've been able to gather. And looking at the screen now, this is a typical example of an output from an Autodesk Inventor. I was talking about a adjustable table for putting computer, and at the end of it all, we're able to come out with something like this. So this is what a typical computer-aided design looks like. But if we have computer-aided design, the next thing we want to talk about, having gotten our model, is that we want to look into the manufacturing aspect. The model is like a soft copy, it's on your system. But we are not ending the project with that one. We want to go further to actualizing what we have been able to draw, what we have been able to model, what we have been able to design. So we go further by talking about the manufacturing. That is where the computer-aided manufacturing comes. It's just a model of manufacturing things. When you compare it to the conventional method or the traditional method in which people use manually they join parts together, they join sub-assemblies to make a product. But we're talking about using those things or doing those things with the aid of the computer. That is why we call it computer-aided manufacturing. And it's a modern way of manufacturing now. In order for us to accomplish that computer-aided manufacturing, since we are having an output from our CAD file is a soft copy of what we are having as our design now. And now we want to transfer that particular CAD file to a machine to be able to for us. So the next thing that we want to do now is talk about the computer-aided manufacturing. It's just the use of software with some computer-controlled machines. Computer-controlled machines called CNC. We want to combine the software that we have worked upon, the software that we have used to design our project, the software that we have used to design our model. We now want to translate those things into real objects. That is when computer-aided manufacturing comes in. And like it's on the screen, so I said computer-aided manufacturing relates to manufacturing. Unlike the CAD that relates to design. The CAD, that is the computer-aided design, relates to design. Computer-aided manufacturing relates to manufacturing. So when we are talking about wanting to manufacture something and we want to use our computer, not really using manual method of doing it now, we talk about computer-aided manufacturing. And the good thing about this too is that most times we are able to control some things. And it's a normal thing. When you compare things that a computer is able to do to bring out an output, and you compare it with a manual one, you see that there's a lot of differences. There's a lot of differences between those things. The good thing about this computer-aided manufacturing is that it has a very high accuracy. What you just need to do is to put in your points, to punch your values into the panel of that particular machine that you are using. And everything comes out as you have programmed it. And the good thing again is that it helps us to save cost. When you have a very high accuracy in what you are doing, and you are able to save cost because it doesn't waste material, and you are able to improve quality, automatically you are increasing productivity. And the good thing about this computer-aided manufacturing is that you are able to save your data, you are able to save your information, you are able to save your findings for you to look into later on if you desire to do, for you to make one adjustment or the other to it so that you can come up with something different. And just like engineers, CAD is also a very versatile and flexible software that we can use to do anything by just making a little adjustment here and there. Let me mention some machines that are quite compatible with this computer-aided manufacturing. We have, of those machines as listed on the screen, we have the vertical machining center, we have 3D printing, which is very common now. 3D printing is very versatile. It's just like I want to compare it to the normal work our printer does. When we type our document, we go to the printer, we try to print it out. The same thing with this 3D printing machine. But now we're talking about printing out a product that is 2 or 3 dimensional. You know, 3 dimensional. You have worked on your design, you have gotten a model, your model in 3 dimensions now. Now you want to print out something in 3 dimensions. That is what the 3D printing does for us. And the good thing about it is that, like I was watching a documentary recently, it's not just about printing plastic or printing things, but you can even print metal. When you have a design and you want to print it out, you can use it to print plastic or metals. And we find the use of this 3D printing machine is very versatile. People now use it in dental, in hospitals for making dentures. You know, they use it in what we call a prosthetic foot or part of the body. You know, different applications of 3D printing. And then some other machines too that we have is that we have what we call the laser cutting machine. You know, that does your cutting for you in a very neat way. Then the same thing we have laser welding machines. Then we have milling machines, lathe machines. These are just some of the machines that are compatible with computer. We call them computer numeric machines. Other ones are the rapid prototyping machines. This particular rapid prototyping machine is a kind of subtractive manufacturing machine. You know, you want to manufacture something, but you want to remove some parts from your stamp, from what you have on ground before you arrive at your final product. Then again, we have the coordinate measuring machine. Basically, we use the coordinate measuring machine in getting our data. Actually, when we have a complex sample of what we want to fabricate or manufacture, when it is very complex, you can take it to the we call it CMM. You can take it to the CMM to get your data, to get your information about that particular product that you want to do, to get it out for you. So these are some of the machines that we can use when it comes to computer numeric machines. There are many of them. I just decided to put some of the examples there. So basically, like I said earlier, I said, when we have a design already done with CAD, that's computer-aided design. Our files are stored in CAD. So what we'll do is that we need to communicate that particular CAD to our CNC machine. And what helps us in that communication is what we call the CAM software. You know, you export your software, your CAD software from your computer system now. You now want to import into a CNC machine. So by the time we're able to do that one, it helps us to produce whatever thing we want to produce, whatever thing we want to fabricate, whatever thing we want to develop, without really going through the manual process. And you know, like I said earlier, anything that is being manufactured using a computer, using different codes on the system, goes a long way better than the manual one. It is faster, you know, it is more beautiful, it comes out well, it is precision coincides, as in whatever thing you put is what you will get. It is quite, the precision is very accurate. You know, compared to the manual one can make mistakes. No, computer does not really make mistakes. This is what we put into the computer system that we get out of the computer at the end of the day. So, in this current dispensation of modern manufacturing, the use of CAD, the use of CAM is very important because of the different advantages that we have. But just like I've mentioned, the good thing about this CAM manufacturing is that it has its own limitations too. And some of its limitations is that because of the different kinds of software that is involved, it may be expensive. It is expensive. It's not even a matter of it may be, it is expensive. And you know, getting people trained on the use of this software too, it costs a lot of money. So the training is expensive, the machine itself is expensive, and the computer errors too is possible. There are times if your machine is, you know, getting faulty and you input something, it may give you a nothing. So these are some of the challenges that we have with computer-aided manufacturing. But the truth of it all is that irrespective of the challenges that is as listed, it is still the best way of manufacturing. It is still the modern manufacturing. And the product that you get from it cannot compare with whatever product that is done manually. So that's one of the good things about it.
Engineer OLORUNTOBA, I would like to cut you at that point and maybe ask this question. We all, you know, understand how a computer can help to design. But how much of computer aid manufacturing do we have? For example, the example you gave in your presentation about an adjustable, manufacturing of adjustable table, for example. How much of computer aid manufacturing have we seen, do we have locally in this country? Okay, but before you answer that question, we have a caller, Bishop from Owe. Hello, Bishop.
Good evening. Good evening, sir.
Good evening. How are you?
Fine, sir. So I want to answer the question.
Okay, you want to answer our question? Go ahead.
The child is 20 years old and the father is 60 years.
Come again, Bishop.
The child is 20 years old, while the father is 60 years old.
The father is what?
60 years.
All right, I'll let you know, Bishop, if you are correct. Thank you so much for calling.
You're welcome.
All right, so Engineer Oloruntoba, please, can go ahead now.
Okay, thank you for that question. Let me use my own case as a typical example. Okay. I remember when I was in school, as an engineering student, then we all did design, you know, and I remember the time I was doing this, what's it called now, this technical drawing, you know, what we were doing then was to carry boards, drawing boards everywhere we went, you know, trying to do our design on the board. But things are different now. That is why we are trying to encourage our young engineers. You know, aside from having your educational qualification, go out of your own way, acquire some skills. Those things are quite available. They are all around us. So it is now on your own. The onus lies on you to go and acquire that skill. Whatever thing, to go and make sure that you had one or two skills, one of these engineering design methods, you know, as a skill to your qualification. So by the time you think there are many of them around in the country now, we can't say we are new to this. Computer-aided design design softwares are everywhere, and they are in every field. And it now lies on young engineer to go acquire that knowledge to add to his own CV. But it's everywhere. It's not a new thing. We have it in Nigeria.
All right. Lastly, okay. before we go, because our time is running. Okay. The fear of most people when it comes to this computer-aided manufacturing is that it will get some people out of job. How true is this?
You know, thank you for that particular question. Let me take the banking sector as a typical example before I answer your question now. People said with the advent of use of ATM and stuff like that, that it's going to take some people out of job. But the question is, how many people are out of job? The more you are developing a solution to something, the more you are having more problems to even solve. The same thing with computer-aided manufacturing. We are trying to resolve some problems by not doing some things manually. But the IT personnel now, the engineers now, they will still have some things to do because your machine will be developing some fault at the end of the day. There are still some challenges you still be facing with that computer-aided manufacturing that people will still need to solve. So it's not that it takes people out of job totally. I don't agree with that.
All right. Lastly, this program is actually meant to encourage young Nigerians to go into engineering. Okay. And it's sponsored by Prince Engineer Yemisi Shilon. I don't know what it is it that you would like to say to him, especially in this time when you have this opportunity to talk about it.
Okay, Engineer Prince Yemisi Shilon, I must commend your efforts for training our engineers. There's nothing as mentorship, you know, and that was one of the things that I never really had that privilege of having. When somebody is mentoring you, when you have somebody guiding you, try to not repeat the mistakes that people have made before. I think it's a good thing, and it deserves our round of applause for that. Engineer Shilon, well done, sir. Thank you so much for mentoring our youth, and thank you for this program.
All right, I would like to say thank you to you too, Engineer Dr. MOJIRADE MONSURAT OLORUNTOBA. Thank you so much for joining us all the way from Akure.
Thank you for inviting me.
And we hope that when next we have to call on you, you would answer.
No problem. That will be my pleasure. Anytime, any day. Thank you so much.
All right. We have to end this program for today, and the first one for the month of September. And today we have a winner of our prize, and the winner is Bishop from Mowe. The answer to the question is the son is 20, while the father is 60. So Bishop from Mowe, you can give us a call. The number to call is 003-684-7505, 003-684-7505, and your prize will get to you. Courtesy the sponsor of the program, Prince Engineer Yemisi Shilon. And the question for the week, as we go, let's continue the conversation on our social media platform. And the question is, a man kept 6 black, 5 brown, and 7 purple in a drawer. What is the probability of picking a purple shirt with the eyes closed? What's the probability of picking a purple shirt with the eyes closed? If you know the answer, let's go ahead to the Facebook at Ogtv YouTube as Ogtv Abeokuta, and on Instagram as MONSURAT Television. You will sure get your prize, courtesy Prince Engineer Mrs. Shillon, the sponsor of the program. That is it on Engineering and You this week, and next week is another time. We're going to be discussing something else, very, very germane, very important to the engineering profession, and you'll get to know who it is. All right, we have to go. My name is Tunalainiro, and I say bye-bye to you.